All right, my friends, I probably should have warned you in the previous video that you'll need your big kid pants for this one. I'm hoping that between the last video and this one, you have at least tried direct substitution to see what would happen. And so as x approaches infinity, 1 over x should approach 0, not be 0, but approach 0. And so your base down here would not equal 1, but it would approach 1. Okay, so maybe instead of an equal sign, I'll use an arrow, like approaches. Your base is a number approaching 1, not 1, but approaching 1. And then your exponent is a number approaching infinity. And so this is one of the indeterminate forms. Okay, so we do indeed have an indeterminate form, but now how on earth are we going to evaluate it? Because remember, the other green light that we need is we need it to be of the form limit as x approaches c of one function of x over another one, and we certainly don't have that at this time within this limit expression. So there are a couple different things you could try, but one thing I want to draw your eyes to is I want you to notice that our setup here, our setup here inside is a function of x raised to another function of x. And in general, for us, that's been a situation worth avoiding. And the way that we get out of that situation, my friends, is logarithmic differentiation. So just wanted to make sure I could hit you with that stick one more time. Anyway, come to find out, long answer short here, we're going to end up finding out that this limit expression equals e. That's right. The constant known as approximately 2.718. So the natural number. Okay, so let's show how you get there. The first thing I'm going to do is let u, or any letter you're not currently using, equal this entire expression. And then the next thing I'm going to do, again, in efforts to get out of that f of x to the g of x situation that I see there inside my limit, is I'm going to take the natural log of both sides. There we go. The next thing I'm going to do is move the function natural log in through the limit. Like so, and then that will allow me to use the power property of logarithms there on the right side. All right, now notice we still do not have a limit of the form, limit as x approaches c of f of x divided by g of x. So it's going to be a fun little move to get there. Focus on the fact that we're multiplying this natural log function by x, and which is the same as x over 1. So we're going to do the opposite of flip and multiply. We're going to flip and divide. So this limit expression could be replaced with the limit as x approaches infinity of the natural log of the quantity 1 plus 1 over x over, and multiplying by x is the same as dividing by 1 over x. Okay, now before we do the next thing, let's talk about this limit, this messy old limit. I just really messed things up, right? But let's talk about what form do we now have. So let's let x approach infinity. So right here, you'd have on the numerator, you'd have 1 over infinity, which goes to 0. 1 plus 0 approaches 1. Natural log of a number approaching 1 would approach 0. And so this limit on the right side, the top number is approaching 0, and the bottom number is also approaching 0. So it turns out, my friends, that this 1 to the infinity case is 0 divided by 0 in disguise. So That's kind of fun. Anyway, but now I can apply L'Hopital's rule because I have all the conditions I need. So I would end up with the limit as x approaches infinity. Now let's take the derivative of this top function. So I'd have 1 over 1 plus 1 over x. And then don't forget chain rule. We need to take the derivative of the inside function, which would be negative 1 over x squared. And then the derivative of the denominator would be negative 1 over x squared. All right, and let's see what we've got. We'd be left with the limit as x approaches infinity of 1 over 1 plus 1 over x. And let the x here approach infinity, and we'd be left with 1 over 1 plus 0, or 1. Now, I did mention that the answer when we're done was not supposed to be 1. It was supposed to be e. But this is the moment for us to realize that this is equal to the natural log of u. So if we need to solve for u, then we need to transition this into exponential form. So what would you take the natural log of to get 1 to be the answer? Well, u would have to have been e. And then not only that, but let's make it super clear. Way back up here, we set u equal to that limit. It was just holding the value of the limit as x approaches infinity of the quantity 1 plus 1 over x to the x. There we go. And I don't require that you memorize this, but there are a couple problems in your problem set that would be a whole lot easier if you did have that memorized. But even if you don't memorize it, now you know the procedure for how to evaluate it. There you go, my friends. There's a grand finale for this lesson. Hopefully everything makes sense, and hopefully you'll ask me questions for the parts that don't. Take care, everybody.